have here, which is encapsulation. Encapsulation, you can remember these four words. Abstraction, again, means like abstracting away unnecessary stuff. I always remember encapsulation with this capsule word that's inside of encapsulation, right? So it means like putting something in a capsule. And the goal of this is to protect something. So let's see what we are actually aiming to protect. So somebody can easily go ahead and say that this person's age is a negative 35. And this is not really good. This will cause our programs to misbehave in all sorts of unpredicted ways if you can simply set any value that comes to your mind to any variable. So in order to prevent this from happening, we have a mechanism in Java, which is called encapsulation. This allows you to put stuff that you need to protect in a capsule, right? Or to protect them. This is done here in the class, and you should use these words that go before the variable. So to protect something, now it's not protected. Now it has no words here at all. In order to protect it, you simply add a private word in front of it. Private means you cannot access it anywhere outside of this file. So now you can see this age turns red here, which means now it's not accessible directly anymore. We can only now access it indirectly, and this allows us much higher level of protection. And we're going to see right now how that works. So basically, as you can see here, encapsulation in Java is done using these access modifiers, as they're called: public, private, protected, and so on. So you might notice that there are a couple more. You notice here that the class is public. This is literally allowing anybody to use the class. Making something private allows only you to use that thing. There are two more modifiers: protected, public, private. Those are three, and no modifier at all is the fourth one, right? So there are four levels of protection, and we are going to only mention private thus far. And public, public means anybody anywhere can access it, and private means nobody nowhere can access it. And these two other ones are somewhere in the middle. So we're going to explain those in a couple of lessons when the time comes. Just for now, know that you can make something, if no modifier, it will be as protected. It'll be similar, Farouk. It'll be kind of similar. No modifier and protected are somewhere in the middle. You can see like here, protected allows me to use it here, but if I was in another package, it wouldn't allow me. So I'm not going to bother you like with the exact specifics. For now, just know making something private makes it inaccessible to anybody anywhere other than you inside of this file. So how do you then use this? We need to provide an alternative way to accessing this. Because yes, you obviously cannot access it directly, but you can access it indirectly. So we're going to create something that's called getters and setters. And we're going to fully explain getters and setters, I think, in next lesson as well. For now, let's just briefly do it. You create a method, right? We know what methods are. So let's create a public void method. And let's call it set age. It's simply going to be used to set the age to some value. And here we need to take the value. So we need to take the age 1. And this is a good time to talk about that variable shadowing that you guys might remember. Now, you also might notice that there is a lack of static keyword here. It must be non-static. And now, next lesson is literally called static or something like that. So I'm going to fully explain that then. I know I'm saying that a lot, but there's so many things to explain, so bear with me. Next time we'll explain static fully. For now, just know making this static will not allow you to use these variables because like age now doesn't exist, or static stuff belongs to the class rather than an instance. Again, not bothering you with that right now. If I remove the word static, age becomes available. So now we can say age equals age 1. And this is usually not how it's coded. Usually you name the variable literally the same as the variable you're trying to set. You name the parameter, literally the same. And then age dot equals age wouldn't work. So you just do this dot age. So this is how setters look in Java. You simply set a value of this dot age, and this is again circumventing the variable shadowing that was mentioned, I don't know, a couple of lessons ago when it was not the time for that, and now is the proper time to talk about that. So when these things are named the same, this age and this age, we can differentiate them by using this keyword. This tells you look in this class rather than the method's parameters. So without this, it's just referring here, and with this, it's referring here. And IntelliJ nicely colors all of these things, like this is colored differently than this. Okay, so this is always the convention in Java is to make all of your class variables or fields, as they are also called, like fields as they represent some data about an entity. So they would be fields in a table or something. So that's why they're called fields. It's always a convention to make all of your fields private. So to encapsulate everything and then allow access when you need to. And why is this different at all? Like, how is this different than simply allowing anybody to use, well, directly the variable? Here, I can still say set age. Now I can call it with a method, and now I can pass 35, negative 35. So I didn't really do anything, you might think. And here I can say set age to 30. But I did do something, because here, this is a method. So rather than simply assigning a value as person2.age equals -35, we have literally no control over this. It's literally an assignment operator, and we're putting a value in there. Here, we're calling a method, and methods can have bodies, and bodies can allow us to perform checks, which is something like this. We can say if age is greater than 0, then set it. Otherwise, print a message, age cannot be negative, and maybe set the age to a default value, like this.age equals 0, something like that. So we're never allowing age to be less than 0. One huge side note, you'll never see code like this. I'm just writing it like this, so because this is our current level of knowledge. Usually, you will not print anything from here, nor will you set it to a default value. You will rather throw an exception, but we don't know exceptions yet, so this is okay for now, but we will, of course, do this in a much better way soon enough. So literally, you're saying here, okay, if that you are passing as a parameter is valid, I'm going to do the setting. Otherwise, I'm going to do something else. This something else will be different in real-world programs. It'll look something like this throw new illegal argument exception. You're literally saying, hey, this cannot be right? You're breaking the program rather than nicely printing an error message and setting the age to 0. But let's leave it like this because, again, exceptions are less than 18 or something like that. So this is now allowing you much more control over what can and cannot be set inside of your variable. And you can imagine this is quite useful. Many things have validations, like you cannot have a person with negative age. You cannot have a square with negative sides. You cannot have a triangle where two sides are not greater than the third one, and so on. So there's all kinds of validations that go into all kinds of programs. So it's really good to protect your variables from illegal state. Because when you have illegal state, when you try to calculate, I don't know, something, for example, you try to calculate the circumference of a circle with a negative area, you get a negative number, and then you add that somewhere, and it causes all kinds of bugs, right? So it's not a good thing to have inconsistent internal state of a variable. Thomas asks, can you show how to set variable at the age with this method? Well, yeah, this is it, right? You simply call set age, and you pass 30 and you pass 35 here, and now we cannot access it, right? I'm getting rid of this, but now what happens if I want to print it? I cannot, right? So we have to provide another method to get the data. This is called a getter. Usually these things, these mutators, and I don't know the right word, mutators are setters, and the other one, I don't know the synonym, but they are getters, right? They're setters and getters. Setters for setting, getters for getting. If you want to make a read-only variable, then you don't provide a setter. You usually do not provide only a setter. You either provide both or only a getter. Some variables you might only want to read after they've been initialized once. You only want to read them. Some variables you might want to allow to be changed later using a setter. So a getter is going to be pretty simple. We just call it get age. It needs no parameters at all, and you just say return age. And this is it. Now we have protected the variable, but allowed access to it using two carefully designed methods that are going to prevent the variable from being in an inconsistent state And this one is pretty simple. I mean, it's just returning a value, nothing more to it. There is no way that you can break a variable by returning its value. So it's not a huge deal. The getters are quite simple. So now in the main program, we will just, instead of age, type get age, and here we will type get age. And we run our program. Set age to -35 will cause that error to appear, which will say, age cannot be negative, and it simply sets it to 0. You can see now when I call person to get age, it doesn't display -35, it displays 0. That's kind of better, right? Again, in the real world programs, this would probably throw an exception telling you, hey, something went wrong, you cannot do this stuff, make sure your input is good or something like that. So keep that in mind.